Welcome to the Thursday morning class. Good morning, everyone. So today, a new topic regarding the Java collection framework. Introduction to the framework, but in details we will use it in practical. Then we will understand what this framework means. Okay, so in the previous class where we have seen generic data type and generic functions. So generic, it's a blank data type, and a data can be assigned to a function in the post definition stage, or in the forward reference stage. That is, you can write the function without specifying the particular data type. That data type will be assigned at a later stage, and all the data type can fit into generic data type. All the data type can fit into the generic. There is not a one particular data type. So that you have seen, and that particular characteristic of now that was about the generic data type. And this collection framework is like a generic data type. uh, is it like a generic data type? So framework, you understand, it's a mm, mm, interface. You can say it's a interface to use to better handling of data, so that data can be put into its right order, or data can be extracted in the order that we want. And so framework is something which is predefined. It's something which is predefined, and we have to fit into it accordingly. It means if it is a data, we have to fit in the data as required by the framework. There are certain advantages of using framework. It makes the data management faster. mm, like if we have suppose if we don't have a concept of array. Suppose when we don't have a concept of array, then to manually go from one index position to other index position, it will be lot of means it not going to be easy. But if we have a array, if a programming language have the provision of a array, then we can only insert, we should only insert the array, and after that if we do I plus plus, then we can go from one index to the other. And that is you can say it is something like it's a already there. Framework is similar to that concept, that some provision of some provision of data management is provided, so that programmer don't have to take all the don't have to worry about the minor background processing. Like if in array, if we don't have this array concept, then the memory management and allocating of homogeneous memory and traversing the memory have to be done by the user. One example is I can give that if you are doing DA and data structure program, there if you have done breadth first search and depth first search, I hope you have it means you are aware of the breadth first search and depth first search, and in data structure and DA you must have implemented also, or you must have get means you must have you must have done it. So how you implement it, you create we create pointers. And so have you done that means I wanted to know if you have experienced breadth first search and depth first search. Can someone say whether you have done breadth first search and depth first search? Yes or no? Means implementation, program implementation. And how you have done it, if someone of you remember. Breadth first search and depth first search. If you have not done, it's okay, but if you have done, just I wanted to know if any one of you have done. Okay, anyway, in the breadth first search and in the breadth first search and in the depth first search, the data that is uh, uh, created is to be created manually. That is, you yourself have to create the parent node, and then we have yourself have to create the tree and then traverse from one node to the other. Either it is by in the breadth first or in the depth first search. Mostly a recursive algorithm is used, and but so that is there is because we have to do it all ourselves, because there is no existing framework. And similarly, if we have to implement a stack or a queue, then also we have to make the queue ourselves. And how do we create the queue? We take the first we take a array, then we create the front pointer, then the rear pointer, then in insert and dequeue operation happen from the queue. And stack also, if we have to do the stack, then we create the array, then we create the top pointer, then the top pointer point to the element that is in the top of the stack. So this thing you do it manually. And when we have to remove some element from this kind of a data structure, then that is called a delete operation, and then we do it manually. We have to do it manually because there is no existing framework in the C++. There is no provision where the management of the queue and the stack or the tree will be taken by the system, by the C program by itself. Similarly, if we have to make a linked list, then there is no provision that the C program have a inbuilt structure or inbuilt mechanism of creating and using linked list. We have to do it ourselves. We have to create a node, we have to insert data, then we have to give the link, we have to create the link to the next node, then we create the link. And when we have to delete or when we have to insert a node in between, we have to do it manually. Changing of link, updation of link, we have to do it manually. And and these things are useful when we are working with the C program, and it is much better in the C program. If it was much better if it was given some ready-made data syntax where array can be inserted by the user in the form of a stack or queue, but that is not given in the C program. You have to implement it yourself. So you have to when you give means you know how to write a linked list program. So many long lines of code you have to write, and above all the memory management. If you don't manage the pointer properly, then the pointer will point to a node that should not point. Mainly if it is a linked list, then your list will be erroneous if you don't manage the pointer yourself properly. If you delete a node or you insert a node, you have to manage the pointers. And what is the use of this pointer? Pointers basically make the memory management. It have the address of the memory and point it. And stack and queue, what happens is a data structure. In the stack and queue, we cannot predefine from ourselves that how many element is going to be there in the stack. Some stack can be some stack can be 5 elements, some stack can be 50 elements. And if there is a array, in array, if we have a array of suppose size 10, then in the C we know what to do. We have to first define the size of the array from previously, and after the size is defined, then only we can insert 10 element. And if we have to increase the size of the array, then it is not possible. We have to edit the program from before, from the beginning declaration part. We have to give the value of the array to be the new size. If we want the size to increase up to say 12 or 15, we have to do it in the source code, means in the in the declaration part. In the body of the program part, there is no updation of the there is no provision of updation of the size of the array. Like we update the size of we update the variable. The updation is possible in linked list in the body of the program. What the linked list body of the program means, in the main content, which is the program definition, not the program declaration. Declaration part, body part is the separate. Declaration part is the initialization part, or we can say the vector part that defines the program initial and memory areas. And body part of the program basically is the main processing part, and declaration part we can say is the main pre-processing part. And before the program process, the declaration part is, we can say, is the pre-process. Means we have to define everything before the program start to process. And in the processing part of the program, that means in the body part of the program, we cannot change the size of array. But if we are using a linked list, then we can in from the body of the program we can keep on adding new nodes. If you have if you have done linked list, then you must have been means you can recollect what I am saying, that you should able to add new nodes according to your choice. If you want more nodes, you can update. If you want, so there is no predefined size. There is no predefined size that this much size have to be there in linked list. You can keep on adding. Now if the array we want to do the same thing, then it is quite difficult in the case of the C program. Now people have used the C program from ages, 1960s, 1970s. This C program was developed. It is one of the first popular high level languages, and it is used to develop lot of powerful applications, because it gives the user, the programmer, the freedom to manage the memory. So if you are comfortable with handling of memory, then you can do the C program. And if you are interested to use the object-oriented concept of using the C program, if you want to do object-oriented programming, then C++. It is the advanced version of C, where you can declare classes and function and everything. Along with, you can manage your pointers also. Okay, so C is the procedural structural or the procedural part, and the C++ is the object oriented part or the advanced part of the C, where every style of programming of the C is there in the C++. Along with it, the concept of object oriented programming. But now, yeah, people have used C++, but because of the so many uh, core level idea is required more. People who is experienced in C, able to write programs, only very sharp technical people. If I tell you to implement a adjustable, if I tell you to implement a adjustable array, means a array that can change its size automatically, and if you choose the C++ or the C language means you choose the structural concept, and C++ means you choose to implement by the concept of class. If you choose any one of these two, then if the aim of the question is that you have to implement a variable size array, means the array whose size is not fixed from before, and you should able to implement. So you will have to write a very complex set of program, and you will have to know that how to manage the memory. So technical sharpness is required more in C, means you should be technically very sound in order to do such core level, or I should say such kernel level program. C operates in the kernel level very well. Kernel level means you can directly call some of the operating system procedure, because and it gives you the direct address of many programs, and it believes that people who use C are very technically sound. So C library is very powerful tool in order to communicate with the operating system. It does not have any hidden layer in between. You can communicate with the memory management very easily. But what happens is it takes lot of time. Even though you are with good programming expert, it takes lot of time to do this same thing. This memory management, if you have to do this kind of a concept using C and C++, it takes lot of time, and not suitable for teaching someone. Suppose for example, you are a student of computer science, and in the previous semester you have done your linked list program. So, and you have done your linked list program in, suppose, first semester also. Some of you must have done in first semester, some of you must have implemented linked list in your data structure in third or fourth semester. In the wherever you must have implemented linked list pointer concept. And if the same thing I tell you this time, that you have to implement a breadth first search algorithm, then what you will do, you will again have to do the pointer, means using the pointer linked list you have to create a tree. Even though you have you know how to create a tree, but in order to implement the breadth first search, you will have to again create the tree and prove that you are understanding how to implement a tree, which is not the objective of the program. The objective of the question I gave was, suppose, to implement a tree, to implement a breadth first search. I have not told you to implement whether by linked list or I have not told you, but told you to implement a breadth first search. If and breadth first search means you have to make a tree, and tree means there is no fixed size of a tree. Okay, so definitely you cannot use a array. If I tell you to implement a 20 element tree, then you use a array. But if I tell you just to implement a array, each and every student, I am going to, suppose in the exam I give you this question, implement a tree or implement a graph or like this, or implement a breadth first search, then and I will go in entry number. Some student I will enter 5 number, some student 7 number, 10 number. So in from before you cannot fix. So definitely you will have to use a linked list concept where dynamically memories will be created. So in now in your time is wasted in doing the linked list. Your main question was to do the breadth first search. That is the so because that part you have already over in the data structure part, data structure syllabus, you have already learned how to create the linked list. But in the breadth first search, if you want to do the BFS program or if you want to do the DFS program, then that concept will help you to understand the program. But in the normal class time, it is okay. In the normal lab, it is okay to do the linked list program from before again and implementing the tree. But in exam, if you have to do it in the because in exam, if it was possible that C provided some framework where the tree will be ready-made created for you and you just have to enter values and do the breadth first search properly. No need to worry about the background processing of how the tree is created. If you want to create the tree in the class practical lab, you do it. How many hours you want to take, 10 hours, 5 hours, 16 hours, you take your time and implement the tree. It is okay. So you'll understand the background processing, how it works and everything. But in exam time, if is any possibility was there, C++ is it provides some framework which in exam you can use but not in the lab class to do such things. So Java have that. Java gives you the freedom. There are many reasons why Java gives a user a ready-made tree. Java gives a user a ready-made stack. We don't have to create the array. So stack is a now we are coming to the advanced section of this Java. You will see now stack is a data type in Java, queue is a data type in Java, linked list is a data type in Java, tree is a data type. So everything is predefined from before, and to implement this data structures, some advanced concept is required, the concept of this collections framework. Now you understand that it provides a interface so that user can manage the data, and collection means it's a collection of values. And what are the data structure that is providing the collections? Stack is a collection, array is a collection, linked list is a collection, queue is a collection, tree is a collection, hash table is a collection, set is a collection, list is a collection. So there are different set of collection, and Java have a ready-made function and classes inbuilt into it, like the comparable class. Comparable class is inbuilt into the Java. Similarly, this linked list, stack, queue, array, it's all inbuilt in Java, and we can use it and it provides other advantages also. We will look into this, that why Java provides it and what are the advantages of it, and in the coming classes we will see the implementation. Firstly, as we know, in Java, as we know in Java, as we know in Java, it does not provide memory management. That is the pointer that is not there. We cannot assign pointer to pointer to the basic data type. And if we have a if we want to create a array of a variable, if we want to create an array of a variable size, then how will you implement it in Java? In C++ it is okay. We can tell that sir, we can create a linked list where one link will be one will be connected to the other. But in Java, if you have to create a variable array, then the concept of linked list is not there. Means the concept of pointer is itself is not there. So so how will you do so how will be someone doing it if we have to implement a variable size array, or if we have to implement linked list in Java using the basic pointer. So using references, using using the references, we'll have to do it. But a reference and pointer is not the same. Pointer is using the memory address, whereas reference is only a copy of the variable, only a copy of the address, and not the original address. So we will do that in the practical session, how this linked list can be implemented in Java. uh, but there are issues. There are a lot of issues doing pointer management in Java. Firstly, because it is working in a virtual machine. If we have to now C plus plus have no virtual machine. It gives you the address of the RAM if you are doing the pointer program, and it gives you the address of the memory where your variable is stored. But in Java, if a pointer was given, so it is not given in Java. So pointer programming is not given in Java. If pointer programming was given, then the address of the variable that will be passed is for the virtual environment, which is not applicable in the real world physical machine. So pointer concept is not applicable in Java. Using the pointer, it is not possible to implement. So it is not possible to implement. There is no concept of pointer. There is a concept of reference, but reference and pointer is not the same. Reference is slightly different. It makes a copy of the data, but the original data is kept as it is. We can change the reference. We can change the reference, like if we pass a reference of a array, and in the formal argument if we use a new keyword, then that particular reference is given to this new variable, but if we don't use the new keyword, then the same original array is passed to the formal argument, and inside the function of the formal argument, if any changes we make, then the original data also changes. That is what a pointer should do. But if we pass the reference from the main function, and if in the formal argument if there is a new keyword, so user, it's depend upon the user whether because there is no fixed because this is a implementation issue. It is not a syntax issue. There is no provision in Java to provide the reference. So if someone knowingly or unknowingly uses the new keyword, then even though the array reference is passed for a function, and that we seen in the previous function passed by reference, that particular class, and so if someone uses the new keyword, then the entire array given to the new variable. So if in the formal argument any changes is going on, then the new array changes will be going on. The original array will be kept safe. If someone in the formal argument not using the new keyword, then the reference will be to the original array, and inside the function definition, if any changes happen, it make the changes in the original array. So that is not exactly a pointer. So it is a reference. It is not exactly a pointer. It is a reference. So using this reference we can implement a linked list, but that will not be the same. That does not mean that we are actually managing the address. We are actually management of the we are actually managing the memory values. So it will make it in a virtual environment. And but if we so that is why, since it is not exactly a linked list, not exactly a pointer reference, it is better to use the inbuilt linked list data type. So Java provides a inbuilt linked list data type, and in this linked list data type, arrays values can be in the linked list data type. We can create list, we can add list, we can delete list, and no need to worry about the pointer. No need to worry about the pointer. There are inbuilt function in the linked list data type. Since now linked list is the data type, now what in Java, if something is a data type, means it is a class. So linked list is a data type, means in Java is a completely object oriented program. So since it is a complete object oriented program, every data type is a kind of a class, and it have data and function both together. It have both data and function together, and this function, they have this ability in the linked list class to add a value, to delete a value, to insert a value in a particular position number. Generally in linked list we cannot give the position number, but in the linked list class that Java provide, we can insert value in between, we can delete value in between, we can get the first element, we can get the last element. So there is a ready-made function in linked list called last element. So in linked list return you the last element in the list. There is a function called first element. So linked list dot first element, if you give, then the first element answer will be given by the system as the output. So there are inbuilt functions are there which help us to do the work faster. We don't have to worry about the memory, means how this pointer will traverse from first to last and get the last value, or to insert value in between. These things will be taken care of by the Java system, because virtual memory, virtual environment, it is working in a virtual environment. So there is no point of giving a user the address value, because if Java gives the address value, and if some user, there is a possibility that if some user get the address, he will store the address in a notepad file, suppose. There is a possibility, and that what we do, that is we call writing a program to a file. It is a possibility, because programming languages means what, it has no certain boundary. User can do whatever he want. If Java provided user the memory management using the concept of pointer, then Java will give the user the variable virtual machine address. And if the user store that address in the notepad file, and when the he install the system in the actual machine, when the system will be actually running in the machine, and that particular notepad file will be read by the program in the CPU in the execution mode. Firstly it will be running in the virtual mode, and in the virtual mode it will be running. Once that is once you are satisfied, you run it in the actual system. The program will be converted into the actual machine code, and it will be running. If that actual machine code, the low level language of the system, the 0101, that machine, that language, when the system will run in that system, then that particular notepad address the program will try to read, then your whole program will not work. Now the memory, now the CPU will tell that this is a memory invalid memory, or memory segmentation fault error it will be giving, because that is the address which belongs to the virtual machine. And we do not know whether the actual machine is a 16-bit address, or 32-bit address, or a 128-bit address. In the virtual machine we can create a 4-bit address also, we can create a 100-bit address also, so that because it is a virtual machine, it helps the user to execute the program irrespective of what the background machine is. So if the Java provided the user with the address by knowingly or unknowingly, by knowingly or by unintentionally, if a user save the address and he suppose want to use it in the future for that particular program, and when that actual program will run in the local machine, when that program will run in the machine level, and when the program will read this particular notepad file to add to, because he saved the address of a suppose a array or a table, then that address will give a segmentation fault. But that will not happen in C, and that will not happen in C++, because C and C++ give the address of the proper physical RAM. So even if you save the file into a notepad, that particular address value, and when your program will run in the system, and if you read that particular address value, you will able to locate where your table is in the physical memory, in the RAM. That is the because so that is the difference between Java and C. That why you are learning Java programming, because of this simplicity. Linked list program, you may be very expert in addressing the memory, but it may not be always required. Now if you want to, you may be knowing how to address linked list, how to create memory, uh, then, but if you change your program, suppose you are doing today linked list program, then next time you want to implement a tree program, then next time you want to implement a some other kind of a program where pointer, so you have to start again from the basic. You have to create the linked list, you have to create the node, you have to create the pointer. So these things saves time. Java saves the user a lot of time in doing the background processing. Java will take care of it. In the collection framework, in this particular chapter that we are going to learn, in the collection framework, there are a lot of inbuilt classes, like there is a set, tree, stack, queue, array, list, linked list, array list, table, and sorted table, sorted data set. So these things we will see in the next class.